Very good morning. Today we are going to see a very important topic in this power system operation and control, that is called economic load dispatch. In the yesterday's class itself, I have told like optimal load dispatch. That is nothing but economic load dispatch problem. Okay, so this is the one of the important problems in the power system operation and control. So this problem, mainly the economic load dispatch deals with how cheaply, that is how cheaply we can dispatch the power. That is with how the low cost, by selecting the low cost power generating unit, how cheaply we are dispatching the generation to the distribution system. That is called economic load dispatch. Okay, so in this, like I have told in the previous classes, like so, which generating units we are choosing as a most, like thermal generating units. Thermal generating units we are choosing as a most. So this economical load dispatch mainly we are concentrating on thermal generating units. Why? Because you know how the costly the thermal generating unit is. So we are selecting the. So we are going to solve the economic load dispatch of thermal generating units. Okay, so you can have a question like why especially thermal generating units? It is not for hydro power generating units or renewable. It is there, but we are mostly concentrating on economic load dispatch of thermal generating units. Economic load dispatch of thermal generating units. Like the definition of like economic load dispatch goes like this. Yeah. So what is meant by economic load dispatch problem? Okay. So 2-mark question, one of the important 2-mark question in this subject. What is meant by economic load dispatch problem? Yeah. So the economic load dispatch problem is defined as optimal allocation of generating units to the generating station. Optimal allocation of generating units to the generating station with satisfying the demand, with satisfying the load demand, and also with the minimum fuel cost, and also with the minimum fuel cost. What is the main objective of economic load dispatch? What is the main objective function in another terms? What is the main objective function of economic load dispatch is to minimize the total fuel cost. Minimize the total fuel cost. Say, for example, we are selecting generally, for example, I'm saying, so generally 3 generating units we are selecting. So we have to minimize all the 3 generating units. We have to minimize the total cost, okay, total cost involved in the all the 3 generating units, so that our like cost, like total cost of power production, everything will be minimized. Okay, so once again I am repeating what is meant by economic load dispatch. It is nothing but optimal allocation. What is meant by optimal allocation? I said now, optimally we have to allocate the generating units. There are many generating units. Say, for example, thermal generating units, hydro generating units, renewable power, biogas, wind, like etc. and etc. Many generating units. So we have to optimally allocate the generating units. Okay, generating units with satisfying the demand. So demand also should be satisfied. Say, for example, 1000 megawatt is our demand, means 1000 megawatt also should be satisfied, and also we have to optimally choose the generating units. Allocate in another term, allocate. We have to allocate, okay, optimal generating units. Okay, optimal generating units to satisfy the demand. And also the demand also we have to satisfy. And also we have to minimize the total fuel cost attained in that particular generating unit. Okay, total fuel cost. Say for example, together for 1,000 megawatt, together we are combining 3 generating units are there. It is taking some 10 lakh rupees. Okay, so 10 lakh rupees we have to minimize that cost to some 8 lakh rupees or 7 lakh rupees. We have to minimize the total fuel cost by optimally choosing the generating unit. So whichever the least cost generating unit, we have to choose that least cost generating unit so that our cost of the total cost will be minimized. So the main objective function of the economic load dispatch is to minimize the total fuel cost. Okay, then you might have some question. So Sir said like what is objective? Any problem have objective function as well as the constraint. Then what might be the constraints? Constraints might be, okay, so you have to satisfy the demand. Okay, you have to satisfy the demand. So there are 2 types of constraints, as I already said. First one is equality constraints and another one is inequality constraints. But that is the generalized term in optimization. Generalized term in optimization. But if you choose the economic load dispatch, there are 2 constraints. So the first one is power balance constraint, and second one is power operating limits. Okay, power generation operating limits or power operating limits, all are same. Okay, so or otherwise you write like power generation operating limits. Nothing wrong with it. Wrong in it. Okay, power generation operating limits. So there are 2 types of constraints. The first one is power balance constraints. The second one is power operating limits or power generation operating limits. So what is the power balance constraints is nothing but your equality constraints. Power balance constraints is nothing but your equality constraints. Okay, so then power operating limits is nothing but your inequality constraints. Power operating limits is nothing but inequality constraints. What is meant by power balance constraints? Power balance constraints is nothing but generation that equals the demand. So whatever the generation, say for example, whatever the generation that is happening, that equals the demand. That is called your power balance constraints. Okay, so say for example, 1,000 megawatt you are generating. Okay, your demand is 1,000 megawatt. So whatever the generation that happening, that equals the demand. Okay, that is utilized by their load. Load is nothing but demand. In other words, load is nothing but demand. Okay, so generation that is equal to the total load or generation that equals the demand. That is called your power balance constraints. Okay, so whatever the generation that is happening, say for example, 1,000 megawatt is generating and 1,000 megawatt we are utilizing. That is the load. That is the demand. So generation that equals the demand. That is nothing but your power balance constraint. So what is the minimum and maximum operating limits? Minimum and maximum power operating limits is nothing but, okay, so whatever the generation that is happening, that should be within the minimum and maximum operating limits. Say for example, your maximum generation is 1,000 megawatt. So that should be within the minimum and maximum operating limit. Your generator might be having some minimum. So if you are buying a generator, if you go to your nameplate detail of your generator, okay, that is some efficiency. So maximum efficiency of the generator might be of like a 98% or 97%, 95%, depends on the make of the generator and whatever the thing you are buying. Okay, say for example, a maximum efficiency of a generator is so with some losses, it is coming around the nameplate details, it is claiming around 90% or 95% like that. It is claiming. Okay, so the maximum and also in that nameplate detail itself, there will be a one point like, so you should not run the generator within this RPM. Okay, so if you run, if you take and study the catalog of the generator, you should say, for example, that maximum speed of the generator is 1000 RPM. Okay, 1000 RPM or 500 RPM or 1000 RPM like. Okay, so 500 RPM. Say, for example, 500 RPM is the maximum speed of that generator for generating 1000 megawatt. Okay, so in the catalog, if you read now, you should not cross the speed of the generator from you should not cross like 200 RPM is the minimum RPM. Okay, you should not go beyond the 200 RPM, and the maximum RPM is, say, for example, 500 RPM. You should not go beyond, say, for example, 520 RPM or 530 RPM. Okay, so if you go beyond the 530 RPM, then your efficiency will be, so your lifetime of the generator, if you're running the generator to the maximum RPM, more than the maximum RPM. So maximum RPM itself, it is coming around 500 RPM. You're running that generator, you're overloading that generator to 530 RPM or 550 RPM. Then meanwhile, the life of the generator might be decreasing like anything. Okay, you can't expect. So in the catalog or in the warranty card, they are giving like lifetime of the generator is with the service 1 year service warranty they are giving, and the maximum lifetime they are giving, say, for example, 10 years they are giving the maximum lifetime, or otherwise the number of operating hours they are giving. Okay, say, for example, daily you're running that generator for 8 hours. Okay, so 8 into some 10,000 hours. So like 8,000 hours or 10,000 hours, that is the maximum life of the generator. Like that also they are giving. Okay, so it depends on how many years you are running. So daily you are running 8 hours means, so it will come around some 10 years. Say, for example, it is come around 10 years. Daily you are running that same generator for 24 hours or some 20 hours means that lifetime is only it is coming around 7 years. It depends on the operating hours. So in the nameplate itself, they are giving in the catalog of the generator itself, they are giving the maximum operating hours of the particular generator. So if this is the maximum, it can also run. It can also run with the proper maintenance. If you are properly maintaining the generator, it can also run beyond that operating hours also. It is not like a use and throw. You are maintaining regularly. You are maintaining the shaft of the generator like once in a month or 20 days, 10 days in a while. You are okay, servicing the shaft and coil, you are testing, everything you are maintaining. Then it may come beyond that hours also. Whatever the company is claiming, it is coming beyond that. So if you see in India, like a majority of the hydro power station, okay, so it is running beyond 100 years. Okay, so many generators, many hydro generators are there. Okay, so it is running beyond 100 years. 100 years, it is running beyond. Even like some ABB make company, like old make like generators and all, it is running beyond 100 years. Even the company itself, it's astonishing. Like our generator is running beyond 100 years like that. Okay, because the company itself giving the life of some 10 years, 20 years like that. But even the old German make and Italy make, then UK make machines are there. Like it is running beyond. I am saying, no, 100 years old, 100 years. It is running beyond the 100 years. So many generators are still it is running. Still that generators are running. Okay, so how it is possible now? It is only possible with a proper maintenance. What they are doing is proper maintenance. Previously, for servicing, say for example, if you want to replace that particular shaft or even a bolt net, what you have to do is you have to go to that particular country, okay, Germany or UK or Italy or some Japan. You have to go or China. You have to go to that particular company and you have to get that particular shaft or even bolt net. Then even some many parts are there. Na? You have to go and get from that country only. Okay, so what they will do is they will keep the servicing order of you have to maintain the shaft of the particular generator. So if you give us a photo, okay, snapshot of that particular shaft or particular parts, so what they will do is they will go and verify their catalog. So this generator is which year make, say for example 1900 make. 1900 make now. So what type of shaft we have to manufacture? What is the dimension? Okay. So what is the bolt net dimension? So it will be manufactured and they will be sending to us. Okay. So nowadays, due to the technological development, we can also make the same shaft or the same bolt net and all. Okay, like that. So and also servicing. Previously servicing, if you contact now, they you have to wait for 1 month. By the time that generator will not run. Okay, so you have to wait for 1 month. Okay, some servicing person has to come from that particular company or particular country for servicing. Okay, nowadays due to the technological advancement, so locally itself they're making the servicing. Okay, but previously that particular, say for example, 1000 megawatt plant has to be off for 1 month. It has to be because servicing has to be done. Okay, so frequent servicing, small servicing they can do, but major thing, if you want to replace the winding or replace some parts inside the generator, so you have to get from that particular company only. Okay, so it will take time consuming, maybe some 2 months also it may take, some 3 months. So the 60 days, that particular 1000 megawatt will be off now. So again, the power deficit will come. Okay, like that also there. So even though stages, maybe some 1 or 2, 3 stages might be there, but I'm telling about in the old age, some 30 years before. Okay, 30 years, 40 years before. So we have to wait for that particular company for servicing. People has to come, like. So nowadays, due to globalization, so we are getting the servicing here itself, iPhone service. So we are getting here itself. You can't able to go to USA and you can't service there, and again you have to come back like that. So nowadays, even in villages, even in cities, towns, everything you can anywhere you can find the servicing stations of your iPhone or any other Android mobile. Okay, you can't go to that particular China or Korea, South Korea, North Korea to service that particular mobile, and you can come back. Okay, so that is due to the globalization. So like that. So minimum, there will be some minimum speed. Minimum speed you should run that particular thing, and there is also maximum speed, and also that particular generator should not go beyond, say for example 1000 megawatt generator. It should not go beyond the 800 megawatt, and also it should not go up to maximum 1050 megawatt or 1020 megawatt. Okay, so if you are operating that particular generator, okay, the particular maximum capacity of the generator itself, you can generate around 1000 megawatt. But what we are doing is we are overloading the generator. We are running that we are running that speed. We are increasing the speed, and we are generating the maximum power up to 1020 megawatt or 1030 megawatt, like that. Okay, 30 megawatt we are running more. Okay, what will happen? Automatically, your the lifetime of the generator will come down, and that should not you should not run the generator with the minimum speed also. Minimum speed also you should not generate. So what happens if you run the generator in the minimum speed? Now the efficiency will be getting dropped. Okay, so if the efficiency is going down up to some 50% or 60%, okay, beyond that, so what will happen is definitely, so we are spending huge amount of money. Okay, if we are not getting the maximum efficiency, means that is the loss for us. Okay, even that if you are running the generator, that is of no use. If the efficiency is coming down up to like 60%, 50%, 40%, 30%, if you are running that generator in very low efficiency, then definitely that might be the loss for us, because we are spending crores and crores of amount of rupees for coal for running that particular power plant. Okay, 1000 megawatt we are generating now. If the efficiency is only 50% or 40%, then 30%, that is of no use. That is of no use of running that particular. Even though losses is there, I'm telling about we are running the generator efficiency itself coming down to 40%, because the maximum efficiency of the thermal power plant, okay, that is itself. That is the maximum efficiency of the thermal power plant. I am talking about the efficiency of the generator. Generator efficiency. Generator efficiency is decreasing like anything. I think in the lab experiment itself, you did some to calculate the efficiency of the generator. So what is the efficiency you got? I think around 85%, some 88%. Someone is getting 90%. Someone is getting 85, 82, like that. So like that you are getting the lab in the lab that is of very old machine. So some maintenance is somewhat less. Whereas if you take like in a generating station, so always the maintenance they will do. Okay, so once in a while, 1 week in a while, because they are having stage of generators. So 1000 megawatt means they might be of 4 stages or like that. Okay, 4 into 1000 megawatt stages might be there. Okay, so even today you have to generate 1000 megawatt, means either they may choose first stage or second stage, third stage, depends on whichever is serviced and okay, maintained correctly. They will choose that particular generator, then they can go for the generation. So so that is also there. Okay, so we have to choose the so your generator efficiency should not come beyond this particular limit. Okay, if it is running at 60%, 50%, that is of no use. That is a very huge loss of that power generation companies. Okay, so that you should not do. Okay, so whatever the, so you should have some constraints. You should not run beyond the 800 megawatt and also to the maximum of 1000 megawatt. You should not go beyond 1000 megawatt also, because the maximum capacity of the generator itself, it's a 1000 megawatt. Okay, so that is called your minimum and maximum operating limits. That is the inequality concept. Say for example, sometimes 800 megawatt, it should not cross beyond. This is less than or equal to, okay, less than or equal to, say for example, power generation is happening. You should not go beyond 1000 megawatt. 1000 megawatt. Okay, you should not go beyond 800 megawatt, or it should not cross 1000 megawatt. It should be within the 800 to 1000. It may be either it is less than or equal. Okay, less than 800 megawatt, less than or equal to power generation, that is maximum power generation, less than or equal to 1000 megawatt. Okay, so it might be 800 megawatt. Okay, so I'm adding less than or equal to also, less than or equal. Okay, it might be 800 megawatt, or otherwise 810, 850, 890, 900, 950, 980, 990, okay, or even 995, 998, and 1000. Okay, it should not cross 1000. Okay, it should not cross 1000. So this is your constraints. So whoever is okay, in future you are getting placed, maybe you are getting placed in some of the generation corporation. Okay, your state board generation corporation. So you will be given with a task. If you are a assistant engineer, you are working in a particular generator sector, even in a generator unit you are working. Okay, so you will be given with a task. You will be given with a task. Today's load is say for example 1000 megawatt or 1500 megawatt. So you have to generate that 1000 megawatt. So that will be some limits. Okay, if you are running the generator, okay, beyond this 800 megawatt, say for example 700 megawatt, then definitely you're unfit for that particular job. Why? Because efficiency is going down. Then that is the huge loss of your generation companies. Sometimes you'll get some suspension, or you'll fired from that particular work also. Okay, if you are running the generator like that. Okay, and also the demand unfortunately you should satisfy. Okay, so that command you will get. And this is very, very important, operating limits. Okay, say for example you are running, so demand is going like anything. Instead of 1000 megawatt, it is demand is increasing like 1050 megawatt, like that. So what you are doing is you are running the generator to maximum of. So in the nameplate they are giving like maximum you can generate up to 1030 megawatt, like that they are giving. So what you are doing is you are running the generator beyond 1050 megawatt. Say for example you are running the generator beyond the 1050 megawatt. Then that scenario, in that scenario, if you are running beyond the 1000 megawatt, then you are not a very good engineer. Okay, so you are just like a normal worker. Okay, normal worker, what they will do, they will just note down, say for example in thermal power station, they will just note down the reading. Okay, so they will be given with the training of you can note down the reading of power factor, you can note down the reading of this one limit, generation limit, or frequency, then voltage profile. Just like that, they may note down, or otherwise you have to maintain the pressure of the boiler. Like this step you have to maintain always. You should not go beyond this. Like that, they will just note down the reading. Okay, so they will who will operate? So engineers, so who are all working in that particular unit, that engineers only. So they have to think in the optimal way. They have to think in the optimal way, so that you should not lose that particular company. Okay, because if you're running the machine like that, that might be the loss for that particular company, wherever the company you are working. So that is a very, very important thing. Okay, so what is meant by economic load dispatch? I'm repeating, economic load dispatch is nothing but optimally allocation of generating units to the generating station with satisfying the demand. So you have to satisfying the demand, and also with the minimum fuel cost. Minimal fuel cost is our objective function. So objective function of the economic load dispatch is to minimize the total fuel cost. So that also I'm adding here. What is the objective function? So I'm making shortcuts. You have to note down fully. So what is the major objective function? What is the major objective function of your economic load dispatch? Minimizing the total fuel cost. Minimizing the total fuel cost. Fuel cost. This is the objective function. subject to constraints. I think this thing, so linear equation method, you already studied in your mathematics. Okay, I think without knowingly or unknowingly, you studied, I think maybe linear mathematics. I think in mathematics 3, I think in your BE or BTech degree, mathematics 3. Mathematics 3, you have studied this solving the linear equations, linear functions. I think in control system also you studied. So what is the objective function? Is to minimize the total fuel cost subject to constraints. Subject to constraints. So subject to constraints. There are two types of constraints. So constraints, limitations, all are same. Limits or limitations. Okay. Limitations all are same. Limitations, limits, everything is same. Okay. So in some other books, it might be telling about limitations, subject to limitations or subject to limits. All are same. Constraints, limits are all same. Okay. So subject to constraints. Subject to constraints, there are two types of constraints. So first one is power balance constraints, and second one is minimum and maximum power generating operating limits, or minimum and maximum operating limits. Sometimes in some other books, it is like upper limits and lower limits. Okay, upper limits and lower limits. So minimum is lower limits. Okay, lower limits. Maximum is upper limits. So all are same only. Upper limits and lower limits, like that also they might be using. So upper limits and lower limits. Okay, so subject to two constraints. The first constraint is what is the first constraint? First constraint is power balance constraint. Power balance constraint. What is the second constraint? Minimum and maximum operating limits. This is the second constraint. Okay, two types of constraints. Okay, minimum operating limits or lower and upper operating limits. All are same. Okay. So this is a very, very important 2-mark question. 2-mark question. I think this might be your first 2-mark question in your like exam, semester exam, or whatever the exam you are attending. So I'm repeating once again. So if it is asked, it's like, so what is economic load dispatch? Economic load dispatch is nothing but optimal allocation of generating units to the generating station with satisfying the demand and with the minimum fuel cost. What is the major objective function of economic load dispatch? Is to minimize the total fuel cost. Minimize the total fuel cost subject to constraints or limitations. There are two types of constraints. The first one is power balance constraint. Okay, so nothing but generation that equals the demand. So whatever the generation that is happening, that is equals the load, or that equals the demand. Second constraint is minimum and maximum operating limits. Minimum and maximum operating limits. Your whatever the generation that is happening, that should be within your minimum and maximum operating limits. Okay, so whatever the generation that is happening, or whatever the generation that you are doing, that should be minimum, that should be operate within the minimum and maximum operating